Hello guys, in this video we're gonna see how we can establish communication between different services using RabbitMQ. We're gonna see how we can emit an event to a RabbitMQ queue and then consume it. And we're also gonna see how we can implement RPC, which follows the reply request pattern. So our consumer is going to reply back to our producer with some response. So let's go ahead and see what we have here. I've created two different NestJs projects. I call them producer and consumer for the sake of this video. I used nestnew, the normal command, and I've deleted some files that I don't really need. Now if you take a look inside of our producer project in main.ts, we are exposing our application to the internet on port 3000, so we are ready to take some HTTP requests. Now let's see how we can connect our producer to the RabbitMQ server. Let's go inside of our producer folder, and then here we need to install NestJs Microservices package. If you get this error where it says that we have some conflicts in versions, in this case what solves it for me is using the version 9 for the package. And you also need to install AMQplib and AMQP connection manager. Those packages are specific for RabbitMQ. And now I'm going to open a terminal and then go inside of the consumer project and install the same packages. Now inside of app module, inside of our producer, we need to create a RabbitMQ client instance so that we can send messages to RabbitMQ. To do that, all we have to do is import clients module from NestJs Microservices, and we need to use the register method. It takes an array of different client options, and then here we should give our client a name. It could be anything. This is going to be the name of the injection token that we use whenever we need to inject this client so that we can send messages or emit events. We need to specify a transport. For RabbitMQ we use RMQ, and then we need to pass in some options for our RabbitMQ server. In this case, I'm connecting to RabbitMQ locally on my machine, and then this is the queue name that we're going to be producing messages to. I'm going to call it orders queue. Now inside of our producer, again, I'm going to go ahead and create an orders module. And now I'm going to get rid of some files that I don't really need. So we end up with a controller, a module, and a service. I went ahead and created a route handler, place order, which is of HTTP method post, and we expect an order from the request body. Let's go ahead and create the order DTO. And let's just keep it simple. So we're just going to expect an email, a product name, and the product quantity. So this is how our order DTO is going to look like: the email of the customer making the order, and then the product name that they chose, and the quantity. Of course, we're just keeping it simple for the sake of the example. So now here we can specify order DTO is what we're expecting. And now inside of our order service, let's go ahead and create a place order method that is also going to extract the order DTO, and we're gonna call this method from our controller. So here we're gonna say return this dot order service dot place order, and then we need to pass in our order. Now the goal here is that every single time an order is placed or someone calls this endpoint, we need to send a message to RabbitMQ about this event happening so that some other microservice can consume this event, and then every time someone places an order, the other microservice might maybe send an email of the order just confirming it to the customer. So let's see how this can be done now. We previously said that to be able to send messages to RabbitMQ, we need to create a RabbitMQ client instance, which is what we've done here. And then we also said that the name that we set here is going to be the injection token name that we use whenever we're injecting this client to send messages. So let's do that now. Inside of order service, let's create our constructor and then use @inject decorator to inject a token. And the token name is going to be orders service, which is the name that we specified for our client. And then here let's just call it Rabbit client, for example, which is going to be of type client proxy, which is from NestJs Microservices. And then now if we take a look here, we can see that we have different methods. We previously said that we're going to emit an event and we're not really going to care about the response. So all we care about here whenever an order has been placed is just notifying RabbitMQ and sending a message that this event has occurred, that an order has been placed. So this is why we're going to be using emit, and it takes a pattern and some data. Let's call our pattern order placed, for example, and then the data is going to be the order. So what this does is it simply sends a message to RabbitMQ. Okay, the pattern is going to be order placed, and then the payload is going to be the actual order. And then here we could just return some message, order placed, for example. Now if we go ahead and try to run our server, we're gonna see that we have a dependency issue. So order service is not known. So that's because this client here registered is not global in our application. So one way to fix this is, instead of having it inside of our app.module, we can add it or register it inside of orders module. And of course we need to make the imports. And with that in place, as you can see now, the server is running correctly. And now if we open Postman and make a call or a request to this endpoint, okay, with email, product name and quantity, so we're respecting our DTO, as you can see we got a message saying order placed, and we didn't get any error, although we don't have a consumer listening to that event yet. And if we take a look here in RabbitMQ management, inside of the queue tabs, we can see that an orders queue has been created now, and we can see that there's one message ready inside of this queue. It's not yet consumed, and we don't really have a consumer yet to consume it. So let's go ahead and fix up our consumer connected to RabbitMQ and listen to that orders queue to receive those messages. So back in VS Code, this time inside of the consumer folder, we're going to go to main.ts, and for the consumer, we don't really need to be listening to HTTP request. It's going to be purely a microservice. So here what we're going to do is nestFactory.create microservice. All we have to do is pass in the app module to our create microservice method, and then we need to pass in the options. So if you take a look here, again we are just specifying the transport protocol. We are choosing RMQ, that's because we're using RabbitMQ as a message broker, and then we're passing in the same options that we have in our producer client. So we have the same URL connecting to our RabbitMQ server, and then we are specifying the queue that we're going to be listening to. So this consumer is going to be listening to orders queue. What we've done is the first step, but it isn't enough to consume the message. As you can see, it is still stuck inside of our queue, inside of RabbitMQ. The next step is to actually register event handlers. So what we need to do is to go to our controller in the consumer, and this is the entry point for our event handlers. So it would not work if you try to actually have handlers inside the service or a provider. It should be inside of the controller. And here we need to use event pattern, and then we need to specify the pattern that we're going to be listening to. And here it's going to be order placed, which is the same one that we are actually emitting here from our producer. And now here let's call this handle order placed. And then here we're going to get a payload. So we're going to use the payload decorator from NestJs Microservices again. And this is going to be the data that we're going to receive. Now we know that our producer is producing orders of type order DTO. So here, let's expect an order, and let's go ahead and create the order DTO here. And don't forget here, this is a different project. The consumer is a different NestJs standalone project. So here again, order.dto.ps, and let's just copy the same DTO that we have here. And here we can specify the type as order DTO. Now inside of app service, let's go ahead and also create handle order placed, which is going to get an order. And here what we could do is we could say, for example, received a new order. And then here we could say, for example, customer, and then we can show the email of the customer. So order.email. And now in the controller, let's go ahead and call this method and pass in the order. npm run start dev. As you can see, we just received a new order, which is customer Jeff. And if you go back to RabbitMQ management here, we can see that there's no more messages. The message that we had here has been consumed correctly by the consumer. Now here typically, for example, you might have some functionality such as sending an email to a user confirming the order that has been placed, and this is inside of the consumer. It does not know about the producer and the producer does not know about the consumer. They are both independent from each other, and RabbitMQ is connecting them both. Just to make sure that everything is working correctly, let's press it 3 times, for example. So those are 3 new orders. If you go back to our consumer, we can see that we have 3 new orders here. So far we've seen how we can actually emit or send a message to RabbitMQ and then forget about it. We're not waiting for a response. And in case the consumer was asleep or down, the server would be kept inside of RabbitMQ. It would be kept inside of the queue up until some consumer wakes up and then receives it and processes it. But what if we have a case where we need to actually receive a response from the consumer? So what if we send a request message and then we're waiting for a reply? Let's see how we can implement that. Back to our producer project, I've created a second route handler of type get called getOrders, which is supposed to get the orders made. Now we're going to assume that we need to send a message to RabbitMQ so that we can receive or fetch those orders from the actual consumer. So to do that, we could use the send method instead of emit. Emit is used if you are sending something and we don't really care about a response, but we use send whenever we have a remote server and we need to fetch some response from that server. So this is similar to the request reply pattern. You send a request, which is the message here, to RabbitMQ, to the actual queue, orders queue, and then the consumer is going to play the role of an RPC server, a remote server that is going to consume the message from the queue and then return a response here using a reply to queue behind the scenes. Now, if you take a look at send, we can see that it also takes a pattern and some data. Now for sending messages, it is recommended by the NestJs team to use a pattern similar to this. So we specify a command, we could call it fetch orders, for example, and then we need to pass in a payload just like we did here whenever we were emitting, but this time we don't really care about sending anything, so I'm just gonna send an empty object. Now back in our consumer project inside of the controller, just like we did with event pattern, we need to do the same, but this time with message pattern. And this time the pattern is this one, command fetch orders. So let's specify that. So we're going to be listening to this. And then here let's call it get orders, for example. We don't really need to take anything here. And let's go ahead and create a method in our service called getOrders. So I've created this getOrders method here, and I've also added an orders array in our app service. And then inside of handle order placed, so anytime we get new orders, I'm not just going to log, but I'm also going to push the new orders into this array so that here we can return the list of orders anytime we request for them. Now, let's see what happens. And just to remind you, inside of our orders controller, inside of the producer project, where we have the route handler get orders, let's make a request to this and see what happens whenever we send a message to RabbitMQ with this pattern expecting to get some orders. So in Postman, in /orders with the type get, if I hit send, as you can see we got an empty array, but if I go ahead and place some orders, 4 orders for example, and hit send, this time the consumer or the RPC server in this case is going to return those orders. If you go back here, if you take a look at the terminal, the consumer terminal, we can see that we got 4 new order events, and we also return those orders whenever we requested them from here. And just to highlight again the difference between emit and send, let's say our consumer was down, so here it's offline, and we went ahead and placed some new orders, so we're sending messages to RabbitMQ. As you can see, everything is perfectly fine here. We're still getting the responses. If you go back here and if we refresh in RabbitMQ management, we can see that now we have 6 messages inside of our RabbitMQ queue, orders queue, waiting to be consumed. So let's go ahead and run our consumer now. And as you can see, we received those orders. And now if you go back, we can see that we have 0 messages ready inside of the orders queue. They have all been consumed as soon as the consumer went up. However, the same can be said if we turn it off again and this time we try to request some data from it. So now we're using send instead of emit. If we hit send, as you can see, we're still waiting for a response, but we're never getting that response because it is down here. The consumer is down now, so it's going to be stuck here up until the consumer is up again. Then in that case we're going to get our response, but of course we don't know how long the consumer is going to be down. So in the case of RPC, whenever we're requesting something and we're waiting for a reply, we could set a timeout here. So for example, we could say .pipe, and then here we could specify timeout, and we could say, for example, 5000 milliseconds, meaning 5 seconds. Now if we stop the consumer again and then try to make a request, it's not going to be waiting for a long time, it's just going to be waiting for 5 seconds now. As you can see, after 5 seconds it threw an error. Of course, you can handle that error in a better way, but this is just to show you that it would be a good idea to implement timeout whenever you're using RPC. Now, in case you want to access some more information about the request being made inside of your consumer, inside your message handlers or event handlers, what you could do is you could use the context or CTX decorator, and it's of type RabbitMQ context, and this way we can see that we can get a channel reference, so the channel, we can even get the pattern. In this case it would return this command fetch orders, or we could also get the whole message being sent. So I've already logged a message here. If you take a look, we have fields, properties, and then the actual content containing the data and the pattern. If you're familiar with RabbitMQ, you know that those are different properties that are present in a message and that can be configured when sending a message. So for example, if you take a look here, correlation ID, this is a very important property and it's being set behind the scenes by NestJs. Normally, if we're using a package such as AMQplib, where we're creating our own RabbitMQ client, we would need to set this value in our code manually, but this is handled by NestJs. Just quickly to explain what this is, basically whenever you have an RPC server, in this case our consumer, so it's consuming a message and then it needs to prepare a response and then return it back to the main producer or the client. So to be able to match which response belongs to which request, since we might have a lot of requests and responses, we would map them using the correlation ID, so this is why it's used. Another important property here in the scenario of RPC is the reply to. This specifies the queue name that the RPC server, aka the consumer here, is going to use to send the response to. So we have our orders queue, which is the queue that our producer is sending messages to inside of RabbitMQ, and then we have this consumer or this RPC server consuming from the orders queue. Whenever they get that request or that message, prepare a response, they need to send that response back to the main producer. To do that, they need to do it inside of a queue, inside of RabbitMQ. So they also need to play the role of a producer to send that message. So we also need a second queue in this case, which is the reply to queue. Now, you might not have known that because this happens behind the scenes. NestJs abstracts all of that work, so we don't really have to tire ourselves with it. I don't want to make this video very long, so quickly, in case you want to actually specify those message properties, maybe modify them, maybe you want to set a priority for your messages, or maybe you want to set an expiration. So for example, we've seen previously that we had some ready messages inside of our queue. In case you don't want them to be waiting forever, you could set an expiration, which would be a time to live. So for example, you can set it for 10 seconds. After 10 seconds, if that message is not consumed by any consumer, it would be removed from the queue. Basically, you would need to create an RMQ record builder, set the options of that message, and then you would need to call the build method. Then after that, you can use send, just like we've done, and you can access those different properties here, just like we've seen here, using this decorator. And that's pretty much it. Also, in case you want to read your connection to your RabbitMQ server dynamically from a config service or from an env file, you could, just like we've seen in many videos before, use factory, and then you would inject the config service, and then here you could return the client proxy factory.create, and then here you set your RabbitMQ options. So this is something we've seen in many videos. It's also present here. So a quick summary. if we want to send a message or produce a message to RabbitMQ, we would need to create a RabbitMQ client instance. To do that, we could use the clients module from NestJs Microservices. And then here we could pass in some options. We need to specify the name, which is going to be the token that we inject. And then we need to specify the transport layer. Here we specify RabbitMQ, RMQ. And then we need to pass in the options that RabbitMQ takes, such as the queue name. This is going to be the queue that we're going to be producing messages to. And then, of course, the URL for our RabbitMQ server. Now, in case we want to use that client, all we have to do is just use the @inject decorator, and then we specify the token name, and the Rabbit client is going to be of type client proxy. And we have two different ways of actually sending messages. We could either use Emit, and of course we need to specify a pattern and then pass in the data or our payload. And with Emit, we just send a message and we don't really care about a response. The message goes to the queue and that's it. On the other hand, if we use send instead of emit, of course it shares some similarities, so we can specify a pattern as well, and we can also send a payload. But the difference here is that we are subscribing to this and we are waiting for a response from the consumer. So here we send a message to RabbitMQ. It is going to the same orders queue as well that we specified here. But this time we are going to be waiting until a response is returned. Now that's it from the producer side. Let's go to the consumer now. If we go to the controller, we can see that the controller is the entry point. So this is where we would use @event pattern and @message pattern. Event pattern is used to handle events. Here, of course, we specify the event name, and then we could have something happen here. And for messages, whenever we need to process a message and then return a response, we use the message pattern decorator, and then here we specify the command. And we also said that we could access the payload by using the payload decorator, and we could also access the context for the request. We can get some more information about that request, about the message maybe, about the properties, and so on. Now, of course, for that to work inside of the consumer, we have to go to our main.ts, and here we should either have a hybrid application or a microservice. So here we went ahead and created a microservice application. We passed in the app module, and then we needed to set the options of RabbitMQ. We set the transport to RMQ, and then we need to specify the options, the queue that we're going to be consuming messages from, and then the URL for our RabbitMQ server. And of course here we need to say app.listen to start the microservice. And with that in place, we are now ready to start handling different events and different messages. So now we can properly consume from the orders queue. If this video was helpful, I would really appreciate it if you subscribe, like, and give me your feedback. If you have any other video ideas, please leave them down in the comment section. Thank you for watching, and I will see you next time.